Hello friends, welcome to all of you Dr. Jackie's Academy. Today I am going to discuss about inductive effect. So in this lecture we will discuss what is inductive effect and how does it actually take place. So let's start. In organic chemistry, we deal with the organic compound in which carbon atoms they are linked by the single covalent bond or double covalent bond. So we have an organic compound in which carbon atom they are linked by the single bond, covalent bond, and the shared pair of electron in a covalent bond may undergo displacement. Either they are displaced toward this side, sigma electron they are displaced toward this side, or may undergo displacement toward this side. So the displacement of shared electron along the carbon chain in an organic compound is known as inductive effect. So when will it take place? It takes place due to the presence of polar covalent bond at the one end of the carbon chain. The polar covalent bond means the presence of more electronegative atom than carbon, or the presence of less electronegative atom than carbon. Here I am taking the general example of organic compound in which carbon atom they are linked by the single covalent bond. So we have at the one end of this carbon atom or carbon chain, we have an atom which is more electronegative than carbon. So A is more electronegative than carbon. And on the other hand, I am taking the example of organic compound. At the one end of the carbon chain, we have an atom which is less electronegative than carbon. The first of all, I will discuss this case. So if there is a presence of more electronegative atom than carbon, then more electronegative means it has more tendency to withdraw the electron towards itself. So this A atom, they withdraw the shared pair of electron toward itself. So when it withdraws the electron, so it acquires partial negative charge. On the other hand, the carbon acquires partial positive charge. So due to the presence of positive charge on this carbon also attracts the shared pair of electron toward itself. As a result, this second carbon also acquires a positive charge. But however, this positive charge is less than that of first carbon atom. So I will denote it that partial positive dash. The magnitude of positive charge is less than that of as compared to this carbon atom. So furthermore, due to the presence of positive charge on this carbon, it also withdraws the electron toward itself. As a result, this carbon again acquire positive charge. So it is denoted by partial positive double dash. Again, this positive charge is less than that of this positive charge. So as a result, due to positive charge on one carbon atom, it means partial positive charge is developed throughout the carbon chain. So in this case, due to displacement of electron, shared pair of electron toward the more electronegative atom which is present at the one end of the carbon chain, so there is a partial charge is developed, and this partial charge is traveled along the carbon chain in an organic compound. But the magnitude of charge they are developed on each carbon, they decreases as with increase of distance from the polar covalent bond. Means as we move away from more electronegative atom, the charge there goes on decreasing. So here the charge produced, that is the triple dash, and so on. So due to the presence of more electronegative atom at the one end of the carbon chain, there is a displacement of sigma shared electron towards this electronegative atom. So on the other hand, we have an organic compound in which there is a presence of less electronegative atom than carbon. So due to the presence of suppose B atom is a less electronegative atom than carbon. So in this case we can say that carbon is more electronegative than B atom. So it means it has tendency to withdraw the shared pair of electron toward itself. As a result, this acquire partial positive charge and this acquire partial negative charge. Again, this carbon, due to the presence of negative charge on this carbon, it also donates the shared pair of electron toward this carbon. Again, this carbon acquires partial negative charge, but this partial negative charge is less than that of as compared to this carbon. Again, this carbon again donate the shared pair of electron toward this one. So this one is again double dash. Again, this one will donate the electron. So it means there is a shifting of sigma electron toward this side. Means we can say that displacement of electron, shared pair of electron away from the less electronegative atom. So again this charge is travel along the carbon chain. And this displacement of sigma electron due to a presence of less electronegative atom at the one end of the carbon chain is known as inductive effect. So we have a two type of inductive effect. If we have a more electronegative atom than carbon, then it withdraws the electron. It means this atom they have is known as electron withdrawing group. So A atom is electron withdrawing group. So due to presence of electron withdrawing group, the displacement of shared paired electron toward this side. And this displacement of shared paired electron is known as IE effect, that is a negative E effect. Negative E effect is developed due to the presence of electron withdrawing group at the one end of the carbon chain. On the other hand, we have a less electronegative atom than carbon. So it means this atom releases the electron toward this carbon. So it means this atom is known as electron releasing group or electron donating group. Due to the presence of electron releasing or electron donating group, there is again displacement of shared electron toward this side away from the less electronegative, and this effect is known as positive I effect. So inductive effect means displacement of shared electron due to the presence of polar covalent bond. So if we have an electron withdrawing group at the one end of the carbon chain, then the displacement of shared electron is known as negative I effect. If there is electron releasing group or electron donating group is present at the one end of the carbon chain, then the displacement of sigma electron is known as positive I effect. Inductive effect is produced due to the presence of electron withdrawing group or electron releasing group at the one end of the carbon chain. So we have a different electron withdrawing group and electron donating groups in an organic compound. So electron withdrawing group there shows a negative I effect, whereas electron donating group there shows a positive I effect. So we have a different functional group or substituent which act as an electron withdrawing group, and the order of electron withdrawing group of these substituent or functional group are as follows. So we have a different functional groups such as a nitro, cyano, carboxylic acid, fluoro, chloro, bromo, iodo, hydroxo, alkoxy and phenyl group. So in this case, nitro NO2 nitro group has that is a higher electron withdrawing group or higher electron withdrawing power as compared to cyano. Cyano is greater than carboxylic, which is greater than fluoro, chloro, bromo, iodo, hydroxo, and hydroxo is greater than alkoxy, which is greater than phenyl group. On the other hand, we have a different electron donating group. So generally alkyl groups are electron donating groups. So we have a different alkyl group, that is a methyl, ethyl, that is isopropyl. This is a tertiary butyl group. So in this case, that is the methyl electron releasing power of methyl group is less than that of ethyl group, which is less than that of isopropyl, and isopropyl is less than that of tertiary butyl. It means as we go from this side, electron donating power goes on increasing, because in this case we have a tertiary, the 3 alkyl group is present, and these alkyl group they have a donating electron releasing power toward this carbon. It means this group they show the higher electron donating group. So on the other hand, isopropyl, we have a 2-methyl group that release the electron toward this carbon. So it has presence of 2-methyl group, so it has a less electron releasing power. There is a presence of 3-methyl group, so it has a higher electron releasing power. So when we deal with the ethyl, there is only single methyl group is present which releases the electron toward this carbon. So it has less electron releasing power as compared to isopropyl and tertiary butyl group. So among all the alkyl, methyl group has least electron releasing or electron donating power. So to understand the inductive effect, I am taking the example of fluoropropane. So in this case we have a carbon chain which are linked by the covalent bond, shared sigma electron. So at the end of there is a presence of fluorine atom. So fluorine, as we know that the fluorine has electron withdrawing group. So it has tendency to withdraw the electron shared pair toward itself. As a result, this acquires negative charge and this acquires positive charge. So due to the presence of positive charge, this carbon again attract the shared pair of electron toward itself. So this carbon acquire the positive charge, but the magnitude of positive charge on this carbon is less than that of this one. Again, due to presence of small positive charge present on this carbon, it also tendency to attract the shared pair of electron. As a result, this carbon again the positive charge, and positive charge is less than that of the second carbon. So as we move away from the more electronegative atom, the charged 12 are of a less magnitude. So this is a displacement of sigma electron toward more electronegative atom. So this is electron withdrawing group. So that is why this compound show minus I effect. So this is a displacement of sigma electron toward the more electronegative atom. So what are the application or uses of the inductive effect? We are using various reactions such as when the methyl chloride react with the KOH or OH negative. So in this case, that is there is a presence of carbon chlorine sigma bond. Again we know that the chlorine is more electronegative or withdrawing group. So it has tendency to withdraw the shared pair of electron toward the itself. This as a result, this carbon acquire positive charge. So when it withdraw the electron, there is a breakage of carbon Cl bond. On the other hand, OH, they seeks the positive charge center. It means OH, they are attack on this positively charged carbon atom to form a methyl OH bond. So this is the form methyl alcohol with the release of Cl negative. So in this case, inductive effect is used in this reaction. Inductive effect is also useful to understand the acidic strength of carboxylic acid, alcohol and phenol. So the acidic strength of carboxylic acid, how will you understand the inductive effect is very helpful to understand the acidic strength of carbon, that we will discuss in the upcoming video. So thank you.